counterparts around the Pacific. It's also a great pleasure for me today to introduce the workshop on water safety plans. As Maria said, it's part of a broader series of workshops that we're supporting under the Pacific WASH Regional Technical Assistance, which we approved just last year in response to the pandemic, recognising the critical role that WASH can play in reducing COVID transmission. The role of water utilities in supporting the enabling environment for improved health and hygiene during a pandemic really can't be overstated. And we have no doubt that those here today would have experienced one of the most demanding years on record, certainly going above and beyond in maintaining service levels to communities amid lockdowns and travel restrictions. The provision of safe water quality is also arguably one of the most visible services provided by water utilities to the community on an everyday basis, normally outside of pandemic times. So it's all the more important for us to focus on how we can strengthen our operational knowledge, our resilience, and share this knowledge with each other. So we're really keen to hear from you during the workshop today, and also through subsequent discussions with ADB program teams on your experiences with creating, implementing, and sustaining water safety plans. This broader ADB TA is intended to provide demand-driven support to you, the utilities, as key stakeholders in building resilience to the pandemic. So we certainly encourage you to reach out to us during and after this event for more support. You already know Maria. There's many others from ADB online, all willing to engage and support with you. With that, thank you again for making the time in your schedules to join us today. And I really do hope that you find this a useful opportunity to gain some insights from your peers and colleagues across the region. And we certainly look forward to learning from you and to seeing you in future workshops. I'll hand back to you, Maria. Thank you.
Thank you very much, DDG Emma. I would also like to mention that ADB could not be holding these webinars without the support from the Pacific Water and Wastewater Association, for whom we are very grateful. So I'd also like to introduce the PWWA CEO, Lucia, to also make some remarks. I think I saw Lucia online before.
Lucia, you're just muted.
No worries. There you go.
There we go. Hi, thanks again, Maria. Well, good morning, Talofa, and welcome everyone once again to this workshop series. We have had 3 workshops so far since we started this series back in November last year. And firstly, with the pandemic planning workshop, the hand washing workshop, and lately the financial sustainability workshop. And so far, we've had the benefit of ADB staff and consultants working in the water sector in the Pacific, but also the engagement and participation of some of our larger and medium-sized member utilities in sharing their experiences and expertise has been excellent, as these make up the realities of what is happening amongst our member utilities and the experiences and lessons to be gained through sharing and learning from the expertise available to us through these workshops. I know the workshops and network created has also resulted in conversations and assistance outside of these workshops, and that is a good sign and a benefit too. For the support, I thank the DG and Deputy DG of the ADB Water and Sanitation Pacific Department for their active and ready support of this collaboration between ADB and PWWA for the benefit of water utilities in the Pacific. This collaboration for strengthening WASH practices and hygiene behavioral change, whilst evolving as a result of the major pandemic we are currently facing, it should be recognized that the development of collaborative relationships that facilitate engagement of multiple sectors and agencies in the water and sanitation sector is key to building strong, sustainable, and safe communities, and also critical in responding to any major disaster, Now, whether that be, health related or a disaster such as cyclones, which is common to the Pacific, I think these would also be very critical for them. Collaboration supports utilities in developing effective planning tools and practices to sustainably manage their operations and ensures water infrastructure investments are cost effective over their life cycle, resource efficient, and support community sustainable goals. So today's workshop will focus on water safety plans, and we are fortunate to have some on the ground speakers from some of our utilities working directly with some of the other expertise around the Pacific in sharing their experiences with development of their safety plans. And I really welcome them to this series. I'll hand it back now to Maria to introduce the speakers. But thank you very much for the opportunity to say something here.
No problems. Thank you very much, Lucy. I'm very grateful for the support that we have received for this TA. So this TA forms part of ADB's comprehensive response to the COVID-19 pandemic in the Pacific and aims to strengthen the capacity of wash service providers and other stakeholders, as well as improve wash practices in the community through behavioural change campaigns. This webinar series is one of the many ways in which this TA is achieving these outcomes. And without any further ado, I'd like to introduce our first feature speaker, Clara Layton. Clara is from Hunter H2O and has been in the water industry for over 15 years and has been involved in a wide range of projects. Over her time in the industry, Clara has become specialized in working with regional utilities as well as small private water suppliers in creating water safety plans. And she is here today to share some of her experience. Clara, I'll hand it over to you.
Thanks. I hope everyone can hear me okay. I did a bit of a test beforehand, so please let me know. I've got the chat up in front of me. So yeah. So I also want to say thank you all for coming today. It's a big commitment for everybody to turn up, and we've got a lot of attendees. I'll be doing about a 45-minute presentation, and then we're very fortunate to have two collaborative partners with us, with the Independent Water Schemes Association in Samoa, with Clarissa and Mazes and Deanna from WAF. So I'll be going through my presentation and at the end then handing to Samoa and WAF for their discussion and their experiences with water safety planning. We'll then obviously have 15 minutes of discussion and Q&A and our closing remarks. So what I'm keen to, how my presentation is going to be broken up is a bit of an introduction in terms of the fundamentals of water safety planning and some objectives and the mechanics. So we're going to go over how to create a water safety plan, and we've also got an actually worked through example to go through, and I'll go through that on the screen on risk profiling. It's a slightly different approach to undertaking a risk assessment, but in practice, I found that this has been really helpful in identifying the areas where you can get the most improvement for lowering your risk to your communities. I'm really keen to then talk about sustainable improvement and talk about the short-term gains you can get from water safety planning, but also about building long-term improvements. And that really then ties into that resilience and response process. So that's just generally how my presentation will be broken up. But to start, we have a poll question, which I was keen to put forward to the group about the key outcomes or objectives for water safety planning. So Dean, if you're able to, or is that myself there? Polls, oh, there we go. So it would be really interesting to get your thoughts on the objectives and key outcomes of water safety planning. It is multiple choice, so you can pick more than one, but feel which one gives you the, feel those that you think are the most strongly related to creating your water safety plan. What I'm hoping to do is, by the end of this presentation, put the same question back up and we can have a look and see how things have changed, or how the presentation may have provoked some different thoughts. So we've got the polling coming in. While this is going on, I think if I can put that on the side there, I think I can do that. I might just talk through, which I thought was quite interesting, is about the introduction and background to water safety planning. So this may be something you're not aware of. We you know, water safety plans are being endorsed by World Health Organization around 2005. And going backwards, Australia was one of the first countries to put it into place, along with Iceland. But originally, water safety planning was came through the HACCP, so the Hazard and Critical Control Point approach, which was actually created in the 1960s with NASA. And the basis of it was to try and ensure safe food for the astronauts going into space. And instead of undertaking ongoing testing of batches of food, or also risking that things might have slipped through, because there's obviously limited support for those up in the spaceships, the Pillsbury and the NASA worked together in the 1960s to develop the HACCP, which was designed to identify those key points in the food process to ensure the quality and the safety of the end product. So I thought that was like an interesting component to just to bring to the room to understand the background of water safety planning. So while that's, I think, oh, here we go. I think we've pretty much come to our end of the polls. I might just, oh, we're sharing. So we've got a bit of an interesting spread of results with an obvious winner of safe drinking water, but good to see that there are some additional considerations in strengthening operations, engagement and knowledge sharing, and as well as centralising and improving data and knowledge. So it'll be really interesting. We're obviously taking note of those results, and we'll relaunch that poll at the end. So I might just now close that one off. Thank you. So what are the principles of water safety plans? Look, this is a summarised extract from the World Health Organization, and I thought this was really a good way of talking about summarising it into three core components. If we can prevent contamination of our source waters, then we've already got a lot of the work done for us. So prevention of contamination of source waters can make life much easier downstream with treatment. So that's a really key point. It's not always possible, but if that can be undertaken as a priority, then some of that work will make it easier downstream, and we'll see that with some of our risk profiling. Following, obviously, is to reduce or remove contamination through our treatment process. And what I think is also really important is prevention of recontamination. And those key 3 points we'll actually be talking through the risk profiling to understand how the risk can change through those key components. So prevention, treatment, and then prevention again. So we want to prevent contamination of source water, treat it to reduce it, and then prevent it again in our distribution systems. So for me, when I distill it down to the three core objectives of creating water safety plans, so this is taking a bit of a higher level, holistic view of creating water safety plans. For me, it's really about getting everyone together and really gaining, as I mentioned, that holistic understanding from the water supply system, from the source to the taps, and really getting a good understanding of the water treatment system, understanding where those risks are and what monitoring needs to be put in place. And also, if things do go wrong, making sure that there are plans and information in place to respond. Then the third component is about over time, really looking at making those improvements to strengthen the systems. So now I wanted to touch on the mechanics of water safety planning. There are a number of different graphics, but the basis of the steps I like, this also comes from the World Health Organization template, is broken into 6 key steps. First is to build a team, to analyse or understand that system holistically from source to tap, look at those hazards and control measures and prioritise risk. Then using that, then to prioritise your improvements, then to lead ongoing monitoring programs to ensure that your systems are behaving as they should, as well as your improvement plans are working for improvement. And finally, continuous improvement in terms of documentation and review. So I'm going to step through these key steps, and we'll then have a worked example on the risk assessment. So getting your team together. So this is a really fundamental key step, and that team should be representative from all key, you should get team members that are representative from all key stakeholders. It's really important there's some consideration that through this process, you're going to be making recommendations and improvements. So it's really important to get engagement from those that are going to be so you're going to be relying on your funding from, or from your governance from. So you may get your key stakeholders from the Department of Health, as well as developmental components from the government agencies. And the other key component is also, which I think is quite vital, is to get engagement with those that are going to operate and manage the treatment system. So those that are actually going to be working on the ground to make these improvements happen and to be having that ongoing, ongoing improvement and monitoring. So when you get your team together, it's important to really put note down who those team members are, and to really understand what those qualifications and experience. So I've got a little bit of a tip example here. That if you can, when you're doing your contributors to experience, and Clarissa, I used you as an example, in fact, I thought you might be okay with that one, is actually writing out what their experience may be directly with the organisation, with that water supply system or larger experience. And that can help do that to summarise what they're contributing to the process and where their focus is. The other one that can be a really great opportunity is involving trainees or juniors. So this process is a lot about knowledge exchange, and while they may not contribute directly, being part of that process can be invaluable in getting them up to speed quite directly, and to get them involved in the process. It also can help to build their confidence. Water safety planning is a lot about talking to key stakeholders, exchanging of ideas, and by getting them involved in that process can really give them the confidence to be part of that process and to contribute. So system analysis, one of the key things about documenting your system is really asking some key questions. What are the major characteristics? Have you got any water quality test results? What are the treatment steps that you've got? And do you know what the quality might be coming out of those treatment steps or out the treatment plant as a whole? Also going back to that, those 3 key points from the World Health Organization is about understanding your piping and your storages, and really understanding the condition of those piping and storages, and if there is a possibility of recontamination. And also, which is quite a vital component of water safety planning, is understanding the risk of interruption of supply or loss of supply. And that may come from each of those key components. So what I find is quite useful as a practical tip is to set up some standard questions to ask in the field, to talk to the operators, create a checklist to collect information, and obviously collecting photos is much easier these days, collecting field photos and even video. For example, when I'm often in the field, sometimes if there is an important description being put through, we can listen to the videos and re-listen to those. And I do that quite often. I put the video, tape the video, and then re-listen to them. Sorry guys, there we go. So what I wanted to document is those 3 key points of what is it, where is it, what is it, and how it is. I think that it's really important that we also think about capturing what is actually the water supply system, not as it should be. So it's really important that we're accurately capturing what is reflected. And these are some practical examples that can be applied in terms of breaking up the water supply system and putting them into key process components. So in looking at the water supply system, we can break that up into, the key, maybe the source water, some screens. You can then group the treatment process up into key components into one group. And then as well as grouping the distribution system. This can be quite helpful in terms of doing the risk assessment process, which we will touch on. But that doesn't mean you can't have sub-units within those components. This is also a practical example that's come from New Zealand, where they've done a very similar thing in breaking up the key treatment processes into major process steps. This is also taken from the Water Safety Plan Rural Template. And this is quite a powerful and simplistic way of summarising using those key groupings about of those key areas of those key areas and key descriptions of each component. What could be also a great tip here is to actually set some of these tables up in Excel to start capturing these key aspects within those key aspects within each of those groups. And then you can actually start creating some powerful tools within Excel on each of your treatment process systems, especially if you have more than one. So what I thought too is we'll just have a quick chat about the risk assessment before looking at the practical example. And what I thought would be quite useful is looking at the risk assessment and understanding some of the definitions with a hazard and hazardous event. So when we're grouping our hazards, the definition of hazard is something that has the potential to cause harm, where the hazardous event is the event or the action that can cause the harm. So I've got a very basic example up here on the screen of just a pothole. And so this is the pothole is itself the hazard, but the hazardous event is the actual action of walking into the pothole and hurting yourselves with the potential consequence of hurting your ankle. In terms of translating that from a water quality point of view, this could be the hazardous group, could be microbiological or microbiological pathogens, and the hazardous event could be rainfall causing contamination to the source water. So that is the hazardous event, is the rainwater potentially causing a high contamination of those hazards. Similarly, a hazard could be the microbiological pathogens, and the hazardous event could be that chlorination fails and disinfection is compromised. So the next step is then now you've got your supply system from source to tap broken up into those key areas. And now the next key step is then to work through and brainstorm those hazards and hazardous events that might apply to each of those key areas. So we're now sort of working more into that risk assessment. And that's what I find quite useful, is just to brainstorm at this point all of those hazards and the hazardous events that could happen in each of those steps. Again, I recommend putting these into Excel, and then you can sort them via the hazard type. In terms of the risk assessment, using the brainstorming method, you can then, once that's been completed, you can then actually rank them using the risk assessment process by looking at the consequence and the likelihood. So this is one of the ones that are recommended. I particularly like using numerical risk assessment tables, matrices, because it helps you identify a risk value, not just high, medium, and low. It can actually show you how you might be shifting through the risk spectrum. So you may do some improvements and you still might be up within this higher risk area. But you actually might be able to reduce your risk right down from a 25 to a 16. And that actually shows you a demonstrated improvement in your risk rating numbers. So definitely recommend using a numerical based risk assessment approach. So raw risk, this is something that I noted isn't as quite clear in terms of some of the World Health Organization templates about looking at raw and revised or mitigated risk. So when you look at raw risk, that really talks about the risk that is present before there are any controls in place. Then we need to talk about what controls are in place, and we reevaluate the risk taking those controls in place. Taking those controls in place into consideration. So for example, using the pothole example, we can do some controls and we can reevaluate that risk. Now we may just determine, for example, using my little graphic up there, the picture, that one safety cone may not be enough to mitigate that risk fully. And so we may actually look at doing some additional controls and that might reduce the risk further. So it's really important when we look at risk assessments to do it raw, without any controls, then we can reevaluate with controls, and that can help to identify how well our controls may be working. And now the really important thing when we talk about controls is they need to be specific in terms of we've got chlorination in place. It's really important there to actually outline what are those targets for chlorination? What are the limits? What are those levels that might be in play? And by putting those in place, we can then develop critical control points. And what's been quite valuable is using something called like a traffic light system. So this can now identify the critical value limits, so what cannot be breached or gone underneath, say for chlorination, an adjustment value of when operators might need to go out there and make some improvements, check on things, increase or decrease to undertake those operational checks in the field. And obviously our what we're trying to achieve is our target values, and these could be an actual number or a range. Okay, so what I've got there is an actual practical example. Again, I've got a link there to be able to provide this. This is what's being implemented in New South Wales, in Australia. And what's really useful about this is it's quite clear on what's being measured, how is it being measured, where it is located, and what those hazards, as I talked about, so those pathogens of turbidity, it quite clearly indicates using that color coding and traffic light system what the target values should be and what the operators should be doing on a normal day-to-day basis. It also provides an adjustment value. So if it goes above this value, it gives some clear guidance of what the operators should be putting in place, and as well as a critical value of what shouldn't be exceeded. And it has some clear direction on what should happen if a critical limit is adjusted. So the approach which has been working really well, is to actually have these printed up laminated or just blue tacked up on the walls or on pin boards. And this can be put into place within the treatment plants as well as in laboratories. We've also seen ones for the reticulation system being put up in place, such as in those clipboards for the guides and the trucks. So they're really visual, they've got the colour system, they're quite clear, and they just help everybody get on the same page of what needs to be done when certain values are exceeded. So we've got the risk assessment and the risk profiling approach. And after this, just quick explanation, I was hoping to go through the worked example, and I've allocated about 10 minutes to go through the risk profiling worked example. So I just wanted to walk it through. It's a little bit different. Like I said, I've been putting this in practice and found it quite useful. What we do is we create a raw risk. We're doing the raw and the revised risk at each of those key steps. And this is sort of pulling together some of the stuff I was mentioning before. So you've divided up your system, you've got a description. And what you do is you brainstorm those risks at that raw level. And then what you do is you talk about the controls that you might have placed in the raw water supply and you revise the risk. Then what happens is you then going into your treatment steps, so the next stage. And what you do is you take that raw risk, the revised risk for your raw supply, and then you put it in and that becomes your raw risk for your treatment system. Then we talk about the controls that are in your treatment system, and hopefully that will actually reduce your risk down. And so now you have a revised risk for your treatment system. So that revised risk is what's now leaving the treatment process and going into your distribution system. So it makes up that raw risk of your distribution system. And then we link through the risks that are associated with the distribution system and whether or not they can actually, in a lot of cases, unfortunately, it actually can increase your risk profile. And what this means at this final point here, you have a final risk to the community, but you've assessed it step by step and understanding how your risk profile changes through your treatment system holistically from source to tap. So the process we usually do this for is each major hazard group. So I mentioned before, you know, that could be microbiological pathogens. You might do one for pesticides, you might do one for nutrients, and you basically do this risk profiling to identify where you're making the most difference to your risk profile and where you can make those improvements. So I'm going to just get out of these slides. I'm also just going to double check I've got the most recent version of my slides. I think there might be a slight problem with that, so I'll just double check on that. And then we'll go through a bit of a worked through example. So I'll just start that off. So this is just an example that I've put together. It's based on my experience. It's very common. We might have a surface water system which may have farming animals in the catchment. We've got some filtration and some chlorination, and the reticulation has some open storages that hasn't been inspected in some time. So our first key step is then to group it. We've got our source water system, our treatment, and our reticulation. Now I'm just going to pop out of these slides and pull up the worked example. So just bear with me 2 moments. So I'm just going to stop sharing here. Thank you. And share. My worked example. Sorry, guys. Here it is. Can we all see that? Okay.
Yes.
Thank you.
Maybe if you zoom in a little.
Yeah, sure.
Okay.
Yeah. So as I mentioned, this is our treatment process. So we're doing the brainstorming. As I mentioned earlier on, we've determined as a group, so we've got all our key stakeholders, our team together. We did consider that bacteria and E. coli was a potential hazard, and that hazardous event would happen during rain events. So our hazard we've identified as the bacteria, the microbiological pathogens, and the hazardous event is that the rainfall brings in the extra loading into the source water. So when we're looking at determining the likelihood and hazardous event occurring, we do have some discussion, and we find that the rainfall events do occur on a weekly basis during the wet season. So what we do is our first thing was we determine that raw risk of the source water with no controls. So if there were no controls, there is no controls on the source water, it's purely as it is, what would be the risk profile? And what we can say is, look, it would have a public health impact on our community. And at the moment, these are happening during the wet season. We're going to be a bit precautionary and go with the worst 6 months. It's happening on a once a week basis. So we're heading towards this 20. So we go, okay, then we have a discussion. That's the raw risk, but do we actually have any controls in place for our farming, for our raw water supply? And yes, we do. So the community's been working really hard to put some bylaws in to prevent farming activities and residents within 50 metres of the riverbank, as well as the community's been working to try to mitigate some of the more weekly minor falls actually getting in within the direct component of the offtake. So we're reducing that likelihood of those events occurring, but the indication is that these monthly events, there's some slightly heavier falls that occur, round about on a monthly frequency, and that still causes some local flooding and contamination. So that these controls on maintaining riverbank stability and conditions have reduced the likelihood to about once a month. So then we do a revised risk profile, and we can go, yeah, okay, well, that's actually dropped it from 20 to 15. And so what we can do then is we go, right, well, we're at 20, putting those controls in place, we've got that 15. So now we go, right, well, going into our treatment system, we know we have a risk level at about 15 with our current controls on our source water. So we know the final risk level leaving the source water going into the treatment plant is 15. So then we talk to the operators at the treatment process, and they say, yeah, we've got some filters that we target less than 1 NTU, and we try to have a residual leaving, the chlorine residual leaving the plant at 2 milligrams per litre. But the team leader says that's what we try to get most of the time, but they're really not comfortable at the treatment plant having anything less than 1 milligram per litre, so they can maintain some residual by the time it gets to the town storage. The operators also indicate that the filters barely breach turbidity targets, maybe once every 5 years. They're pretty confident their filters are robust, but they have noticed that their chlorine levels sometimes drop below the target due maybe to some chemical supply reliability about once a year. So because we're taking the precautionary approach, we really need to stick with the once a year rather than the every 5 years, because relying on that treatment system, both the filtration and the chlorination, to reduce risk. So we go with the once a year, and we can see the treatment has actually now dropped to 10 for a risk profile. So we can see that we've started off at 15, our treatment system now has dropped it down to 10. So we now have 10 moving into the distribution system. So it's moving out of the treatment plant with a risk level of 10 into the distribution system. So we know the final risk level of treatment leaving the treatment process is 10 going into the distribution. So now we have some discussions, and what we've found is that these tanks are open. They're monitored periodically, but they're not monitored as regularly as perhaps the other treatment process. So I just got a chat there. Oh, okay. So, I think, has my slide sharing fallen out there? I noticed there was a message.
We are seeing the worked example.
Yeah, sorry, I'm not sure what happened there. It said it stopped sharing.
Okay, I see some movement now.
Yeah, sorry, I'm not sure what happened there. Are we feel okay? There's a few people asking to zoom in a little bit, so I'll zoom in a little bit more. So we're talking about the treatment system dropping down. Oh, great, that seems like it's working now. Down to the distribution system. And then following that, we have some discussion with the distribution system. And as I said, they're only monitored periodically. The chlorine, when they have gone out there and done some testing, it's often at 0. And there has been evidence, because of the open nature of the tanks, that their birds and animals there have been found them occasionally at the bottom of the tank. So trying to get a feel for that, the hypothetical team has got together and has indicated that they think potentially between a monthly or once a year, because it's not monitored frequently, that there could be the potential for recontamination. Again, because we take a precautionary approach, we go with the once a month. So now we're saying, okay, well, once we reassessed a recontamination impact, we've now bumped back up to 15 on once a month. So we now have our full risk, and I will zoom out just here, just so you can see this graph in full. We still have our full graph here, which shows how the risk profiles actually change through the system. And we can actually see the final risk going to the community is actually at a 15. So what I mentioned, one of the really good ways of good benefits of doing this approach is that you can actually use this to try to brainstorm in the workshop of improvement ideas. So in the group, the hypothetical group, it's discussed that unfortunately, just with the current limitations, the catchment improvements are pretty much at what they can be. So it's going to take a lot of resourcing and cost to do that. However, they can improve the chlorine supply reliability. And that could then, if priority is put on that, they feel comfortable, then that would be more in line with the filtration targets and could line up to maybe once every 5 years. And if the storage tanks could be enclosed to prevent animal access, they feel that this would really reduce the risk of a recontamination to potentially once a year. So hypothetically, you can now see a major, just redoing that risk profile, which risks in likelihood and consequences, you can actually see how significant that can actually change the system. So you can actually now see, by improving your chlorine reliability, that you could drop your risk leaving your treatment plant down to a 5 going into your distribution system. So that's great, but what about trying to target this distribution? So what about if the group gets together and said, look, if we could put a higher vigilance on doing some routine testing and do some manual top-up to try and maintain 0.5, we reckon then we could get the reticulation risk down to what's the same as the treatment plant. And then you can actually see what a significant change that can be made in terms of changing the risk profile from where we started. So from that process, the hypothetical process, the controls and improvements for this particular treatment process is obviously to maintain the current risk levels associated by the source water by keeping in those bylaws and the river catchment protection in place, improve the chlorine chemical supply reliability, enclosing those tanks, and establish new monitoring. And in addition, now we have some critical control points to put up on the wall. So now we know we need to have that target for the filters. We know the operators have given their input, that they are very comfortable that their filters can achieve that 1 NTU. And now we talked it through and we've developed our XYZ operational responses. We know that the treatment plant operators like the chlorine to be leaving the plant at 2, but they're okay between 1 and 2. That's when they might do some operational response, but they don't want it less than 1, so it gets some chlorine going into the reservoir. And we know we want to make sure we get some chlorine in our reservoirs, and we want to keep it above 0.2, which is kind of like that practical 0 for field kits. So finally, the other key step is once that those are in place, it's important that they are monitored and the risk reevaluated after they've been put in place to actually see if they match up with those brainstorming or workshopped ideas of how the risk could be reduced. So it is a very different, a different approach, and what I find quite useful is I'm a visual learner, and I like the visual nature of having the graphs to quite clearly demonstrate. You can put these up on the walls, easy to show how the risks are changed if our controls are put in place. So they're quite translatable and quite clear in terms of how your process changes and what are those key aspects together. So that's a bit of an explanation in terms of risk profiling. Okay, so what I'm going to do, I thought I'd just put it out there for the worked example if there are any questions, and then happy for you to put them through the chat or just to unmute and speak. And I'm happy to answer a few questions on that risk profiling approach, and I'll just get the next lot of slides up. No questions?
No, looks like we're right, Clark.
Pardon?
No questions. Looks
No
like we're right.
questions. Okay.
They'll come at the end.
Okay. Rightio. So I'm just going to grab the slides, and I apologise. I accidentally grabbed a previous version, so I do apologise for that. So I'll stop sharing and go back to the slides. There we go. And I'll just put that presentation back to where we were. Advised risk. Here we go. So the other key component to, as I mentioned, as we finished off about risk profiling, is improvements in monitoring.
Are you sharing there, Clara?
Yeah, I thought I was sharing the slides. Is that coming up?
They're not full screen.
Yeah. You have to enable editing there and full screen.
I might just stop share and try again. Sorry. Enable editing. There's the screen. And share. There we go. Did that?
You can share screen?
No, not.
Not good.
Ah, share. Okay, good. Okay, here we go.
Yes.
Excellent.
Okay.
Thank you. So some of the steps of improvements and monitoring. So as I mentioned, one of the key things about putting, after we've gone the risk profiling, the risk assessment, is identifying those improvements and prioritising them. And that also is quite helpful doing the risk profiling approach, because you can then determine which ones are going to make those significant changes to your risk profile, and obviously prioritise those as of the most importance. As I mentioned, I think setting up establishing your monitoring program, and these can be your water quality tests or inspections or checklists, with a priority on those critical control points that you have established, or those key controls, as I mentioned, like that summary that I had from the worked example, putting those up as your key ones for monitoring, ensuring they're in place. In setting up an improvement plan, I really recommend using Excel. It's a very powerful tool by collating your improvements together, and you can then also sort them. You can then sort them through your different priorities, who they're being allocated to, the dates, or if you've got a number of water supply systems, that can be quite handy. So I've got some practical examples here.
Cara, there's a couple of questions that popped up for you about a typical NTU value around the region.
Yeah, so this would probably be a question I'd put back to your individual water supply systems. So individual water supply systems have their own profiles and can change fairly significantly season from season. So if you do have a dry and a wet season, you actually may have typical dry weather NTUs in your water sources, as well as rainfall event NTUs. So unfortunately, there's not easy answer for that one. It's really dependent on your own system.
So about consideration of risk in catchment upstream activity.
Yeah, so when you do the risk profile of your upstream activities, there, as I mentioned, you can put your boxes. Then that's quite useful, that boxing approach. So you could actually look at your upper catchment, your lower catchment, and your direct water supply system. And you can actually then determine if within the workshop, it would be important to have those key stakeholders that are from each of those key areas, the upper and lower. But you can actually determine if your upper catchment potentially of those activities may actually increase your risk profile. So it actually might increase it. You then look at your improvements that you might have in your inner catchment, and it might actually reduce. Or alternatively, the other way could be looking at, you have a really pristine upper catchment with, basically natural environment, minimal humans, minimal agriculture, and then you actually find in your lower catchment, that's where you have your farming activities and more settlements, and your risk profile could actually go up. So you definitely can include your catchment activities as part of that risk profiling, and would give you a good understanding of the risk posed by your upper and lower catchment. So I think that hopefully that answers those key questions, but feel free to put some further ones up there, and yeah, feel free just to also call out as well. So when you're putting your improvement plan, here are some examples of how you can set up Excel. And this is also a example of Water for Victoria in Australia, of how you can actually then use these in business reports or corporate reporting to quite clearly show how your progress and to summarise those key activities. So, you can turn this Excel sheet into quite polished reporting by, getting those core numbers out of the Excel and then putting them into with some graphics. So ongoing improvements, really important, and review of the water safety plan, and ongoing engagement is a critical component. And my experience tip is to establish quarterly meetings. And you may set up a few different types of meetings. One could be corporately, one could be regionally, and one could be with the team in the actual activities of the community. So short-term goals, so I'm just going to finish off really quickly because I need to keep on top of the time here, is about knowledge sharing and gathering and centralising information. Putting all that information together in one place is really important, and you can get some real benefits. But some of the big hurdles can be if they sit on the shelf. So really, to get that long-term improvements, they need to be embedded into part of the operations. So some of my tips that I have is creating summary versions for the operations teams, getting those procedures and CCPs up on the walls, or somewhere quite visual, and using Excel to collect data to view short and long-term trends. Again, this is an example, and it's actually freely available from, there's a New South Wales link there that you can actually get these spreadsheets already inbuilt with the conditional formatting. So long-term gains is really about behavioural change, and we really need to have those water safety plans awareness at a number of different layers to be able to enable those long-term behavioural change benefits. Pandemics and resilience. So the benefit of having water safety plans in place that are well embedded is that there should be incident response plans when things go wrong. And this could be a typical boil water notice. But in addition, if something goes wrong that hasn't been part of the typical water quality events, there should be enough information in those that they can pick up the water safety plans and help inform those that are working through the response. For example, when we're talking about COVID-19, I do know from some of our feedback that there has been population migration during this recent event of people going back to the precincts. So by understanding that this was going to happen or it had started to happen, be able to pick up the water safety plans, understand what the current capacity of the water system is, if it will support the additional population, what it might mean for if there are going to be settlements close to the catchments that might escalate those water quality risks. So that information should be within the water safety plans to help formulate the response and understand what the limitations and risks associated with an unknown or something different that might happen. So that's a very quick snapshot. As mentioned, we're here to help and to support, but I think now it'd be really nice to hand over to Clarissa if she's ready to really talk about some real life examples within the Pacific group about implementing water safety plans. So happy, Clarissa, if you just say next slide, I'm happy to
yeah.
Continue.
Hi, that's fine. Thank you. Talofa lava. My name is Clarissa Laulala. I am Program Manager for the Independent Water Schemes Association, an organization that was set up to provide capacity building and financial assistance to rural communities that manage their own water networks. Next, please. Some other background information on IWSA. The association was formally established in 2008. Currently, there are 54 villages under the IWSA. We support 10% of Samoa's population. Village water committees are responsible for the overall operations and maintenance of their water networks. And there's currently no centralized treatment for these systems. Next. One of the main challenges for independent water schemes is water quality, since treatment is not provided nor deemed feasible for community level operations and maintenance yet. Hence, drinking water safety plans are considered to be an effective approach to manage and mitigate risks to water quality from source to consumer. In 2020, the European Union provided a funding assistance of 490,000 euro to the Samoa Independent Water Schemes Association in its continued efforts to improve the capacity of communities with independent water schemes to better manage water resources. One of the priority actions under this project is the development of drinking water safety plans for all independent water schemes to systematically assess and manage risks to their water supply from, again, catchment to consumer. Next. So the drinking water safety plans IWSA has developed has a specific focus on community engagement to strengthen the village management of their water supply. The drinking water safety plan process used builds community resilience to climate variability and extreme events by strengthening management and operations and maintenance. Here are the 4 key areas of focus in the drinking water safety plan to overcome the challenges we face with community managed networks. Next. So first one is governance. To assist the water committee's efforts to manage the risk to their networks, as well as the water catchment area, there must be water related bylaws that are enforced in the village for the villagers to abide by. We often find land use such as agricultural activities right where the water source is, where trees are cut for cattle farming and for taro plantations, which negatively affect water quality due to sediment loads, excessive nutrient concentration, and fecal coliforms. And then we hear the community complain their water supply needs treatment because the water is turbid and there's presence of bacteria. We then assume the best corrective action would be obtaining household filters to remove E. coli and other contaminants to the water supply. When we can look at it as a governance issue, if the community was made aware of the consequences due to agricultural activities, then creating bylaws for the conservation of that area and then enforcing the bylaws with heavy fines, the water source would be better protected and the need for filters would not be as necessary. Hence, governance is a key focus area. Next slide, please. The second area of focus is catchment and intake. With communities understanding the characteristics of their catchment, whether it's prone to flooding or landslides, they can better prepare themselves and tailor their O&M accordingly. Other ways to manage the risk at the catchment: encourage tree planting activities, fencing off the intake, 20-meter buffer zone, discouraging use of pesticides in the immediate catchment area. Next slide, please. The third area of focus is water network and assets. By promoting the importance of proactive maintenance rather than reactive maintenance, which is very common in our independent water schemes, we often find during extreme weather events or a breakdown of part of the network, would the water committee then feel a sense of responsibility? We are currently developing IWSA's asset management system. This information is then communicated back to each community. We are assessing the condition of the assets, GPSing their locations, and providing each scheme with their asset registry and a map of their network. We are providing them with the tools to be able to manage and sustain their systems in the long run. Next slide, please. And the last key focus area is treatment. With all other measures in place, we still encourage communities to boil all drinking water for that extra protection, as well as rainwater harvesting, making sure the water is collected using clean rain gutters and storage tanks. Next. So one of the main challenges is ensuring community engagement and willingness to use the plans. When communities think of assistance that's worth having, they only seem to welcome infrastructure upgrades and not so much written plans or capacity building programs. We're now working closely with the communities in implementing their plans so they may see its value. We want to build a solid foundation first, where we use the drinking water safety plans as a monitoring and evaluation tool. So if the water committee has made improvements to reduce risk to their water supply and is undertaking a number of agreed management activities, IWSA will then provide additional support for infrastructure improvements. Next slide. And lastly, some lessons would be to ensure community involvement throughout the entire drinking water safety plan process. Again, as you've mentioned, Clara, develop a short, simplified version of the drinking water safety plan for village community reps in the drinking water safety plan team to utilize. Again, include capacity building training for the community, as well as involving potential donors during drinking water safety plan workshops. So hopefully they may assist in some corrective actions we propose. And I just want to mention some of the strengths. One of the strengths of with the drinking water safety plan process for independent water schemes is that communities have come to the realization after much discussion on their drinking water safety plans that their current water committee is not able to undertake the roles and responsibilities to be able to manage their network. For any authoritative role in the village, priority is always given to the high chiefs or distinguished chiefs in the village, regardless of ability to carry out the role as a show of respect, which is inherent in the Samoa or the Samoan culture. However, through our drinking water safety plan consultations with the village communities, we have highlighted and emphasized the expectation of each water committee member's role. For example, to be physically fit, to be financially literate, to have basic plumbing skills, to be able to sustainably operate and manage a water supply system. We've also recommended the inclusion of women who have proven to have good record keeping and financial management. And also the inclusion of the government employed village mayor and the women's representative who can inform the government of the needs of their community to again support the implementation of their drinking water safety plans. That's all from me, thank you.
Thank you very much, Clarissa.
For our next bit of practical and discussion, we've got WAF available to provide a bit of an overview. Again, similarly, I'm happy just to press the next slide as you go through. So Jose and Diana. Oh, I think you might be muted. Oh, there you go. Yep.
Yep. Mbulabinaka from Suva, Fiji. I'm Moses Senariwa, and my colleague is Diana Langalanga, and we will be both presenting with regards to the Water Authority of Fiji's drinking water safety plan on how we have started the journey in 2015 till to date. Basically, the content of our presentation will be on our vision, mission, and values of water utility, the overview of our assets, introduction, and we'll describe the drinking water safety plan steps that we have undertaken from 2016 till to date. Then we'll move on to the types of water treatment that we have across Fiji, our catchment assessment, our treatment types, our reservoir, our rural, and the way forward. Basically, for the Water Authority of Fiji, our vision is to provide clean water and sanitation for a better life. Our mission, we are committed to optimize water and wastewater services through resilience, innovation, capacity building, engaging stakeholders, modernization, being environmentally friendly, and safe working practices. Our values are under the water acronym, and W stands for that we do the right thing, and A is for accountability, T for teamwork, E for energy, and R for respect. Just an overview on our assets and our operations here in Fiji. The Water Authority of Fiji is the sole provider for treated water utility across the country, and we have 45 water sources. We have 55 water treatment plants across Fiji. We have 92 reservoirs, and we have 132,000 residential connections and 9,700 commercial connections. We have 11 wastewater plants, and we have 30,000 sewer connections. Our main water source. Yes, I will come to that. Our main water source is basically from the surface water, which is 95%, and our groundwater is 5%. I apologize that this slide was, we just sent it 30 minutes before this, and it's unable to be uploaded. And this is the introduction to the content of our main presentation. Okay, next, please. On our introduction, the water safety plan, the process have started in 2015 with the assistance of WHO in conjunction with Ministry of Health. That the training was conducted here at Water Authority of Fiji with the health inspectors from the Ministry of Health. And these have kickstart our task in compiling 55 water safety plan across Fiji. And our reference is mainly from the WHO as described by Clara on the handbook that was used. And I believe that the objectives was also similar for in the compilation of drinking water safety plan is to prevent contaminations of the source waters, treat and remove contaminants, and also prevent recontamination. And for us, in doing the water safety plan, in compiling and ensuring that all the tasks are carried out according to the guidelines, this supports our 5 and 20-year master plan for the Water Authority of Fiji, which also upholds our national development goals, 5 to 20-year development goals for the government of Fiji, and also upholds the Sustainable Development Goal 6, target 3.2, which is the proportion of water bodies with good ambient water quality. Yeah? So this cascaded down, right down to the safety plan. Next, please. Our drinking water safety plan steps is similar to what Clara have described in assembling of the team. And we have different team across different water treatment plants. We have Diana is a water safety plan officer. She's the key person, and above the hierarchy and down the hierarchy of her is changes according to the different water treatment plants that she undertakes her assessment work. Yeah? So the team are assembled and normally goes through the cycle of what has been described by Clara, right? From describing water safety supply, identifying hazards, then identify corrective actions, and so forth, as in the slides. Next, please. For the type of treatment that we have at Water Authority of Fiji, as I've mentioned, we have 55 water treatment plants across all the regions, and we normally have 4 types of treatment. The first one is the full conventional treatment with either pressure filter in place or has rapid sand filters. Number 2 are package plants. The third one is desalination. We have only a desalination plant for the Water Authority of Fiji. And the fourth one is the plain chlorination system, which is just it is without sand filters, and clarifier and filters. Those are just our major plants. A few plants that we have, like that produce 100 mld per day for Waila, for example. We have Nangando in Nandi, that produces 96. And then Tamavua here in Suva, 65 to 75 mld. And Benau in Lambasa, and the rest are in the other cities in the Western Division. So those basically are the different treatment types that we have. Next, please. From here onwards, Diana will be explaining what she normally undertakes, her role as a water safety plan officer, and then I will conclude with the presentation.
We all understand that drinking water safety plan is a comprehensive risk assessment and a management tool that encompasses all supply from the catchment to consumers. Our first visit is to the upper catchment of our water pump station or our dam. We visit the farmers. We make sure that we know the kind of fertilizers that they are using in their daily activities in their farm. We visit villages to understand and know the method of waste disposal that they are currently using. We conducted village awareness and improvement on how waste disposal can be conducted in their village. Gravel extraction, we also visit their site with a quarry, making sure that they know that we have a pump station below that we are all using for drinking water. We collect samples, we tested the water quality on site. We bring full chemical samples to the lab and microbiology for further testing. At our raw water dam, we make sure that screening is in place. Raw water screen, we make sure that the operators are conducting raw water screen that for water pump up to the treatment plant. Next slide, please. At the treatment plant, we make sure that raw water inflow meter that are in place. This is to determine the amount of chemical dose, alum and soda, by conducting jar test method. At the inlet chamber, where alum and soda are injected for flocculation and agglomerations of water. From there, water passes down to the sedimentation tank. We assess our sedimentation tank that all the filter beds are changed.
I think we've lost your audio there, Diana.
Dan, I think it's
Yeah.
guys, the video, yeah, the audio's just dropped out. We can see you fine.
Maybe if you turn your camera off, maybe try, see if that helps.
Can you hear?
Yeah, got you now.
I can't hear them. I can't hear. I can't hear.
Okay, we can hear you.
Yep. We can hear now.
We can hear you now.
Should I go back to the treatment or continue?
I think we could probably continue.
I'll continue to our plain chlorination. Can hear you. I'll go back to the treatment. Okay, plain chlorination. With our plain chlorination system, we either have a borehole and making sure that our borehole are well covered and our borehole are servicing at the right time. With our creek, we also have a creek or dam. Hardly anthropogenic activities are taking above our raw water source, but we are making sure that water are overflowing away. We always check our pipe. There shouldn't be any burst main. We check our valve, that cleaning of them are conducted. We making sure that the accumulation of silt in the dam, raw water dam, are removed. We either use in the plain chlorination system, we either use dosing pump of sodium hypochlorite. We use the HDH tablet feeder, and we use drip dose before water gravitates to the reservoir and distributed to our consumers. Next. We conducted our reservoir sanitary survey yearly, making sure that inlet chambers are covered properly, vents are screened, no rusted ladder, no leaks, no reservoir walls, pipeline and valves, signage are in place, fence and gate are locked at all times. We conducted water quality tests. On-site water samples are collected, both full chemical and microbiology tests are sent to the national lab for further testing. Next. The health inspectors, the Ministry of Health, they take care of the rural area, but in September 2020, the WEF rural team came in to conduct rural training to our rural communities to help the headmen and the water committee in taking care of their drinking water. We've translated our pamphlet in Fijian and we conduct training in Fijian just to avoid the high turbidity in their tap and making sure that they are drinking the clean water. And our goals is to is to install EPS system in every village by 2030. Next slide.
Next, please.
These are some improvements that have been conducted. The sledging of dam, our venta have been screened, our chambers have been changed. We are conducting a post-chlorination where low chlorines were experienced.
Next, please. Yeah, this is the way forward for us in WEF, identifying all those supply component and the hazardous events associated with it, and also the prevention control measures in place. Yeah? As you can, it's in the table for low chlorine. At times that some flushing program needs to be strengthened, and also post-chlorination has to be done in places where the reticulation network is quite large. Yeah? Hydrology, at times we have during an extreme dry event, we are unable to obtain good data, so joint operations there, so that our conservation upstream in terms of the riparian zones and also the deforestation those activities need to be controlled. Environment, yes, lack of environment assessment. This is for us, we need to step up on this, and also the in-depth assessment in terms of our invertebrates. Eh? And for the laboratory, we need also to improve and also equip most of our 55 water treatment plants. They must have, they have it at the moment, but we need to improve and upgrade their testing facilities. Eh? And lastly is our customer services, in which laboratory needs to step up in ensuring that water are tested before water cutting services are delivered to the consumers. Yes, I think that's all from us here at Fiji. I think we are going over time, but
there's a question for you,
we'll be happy to share our water safety plan when required, and we'll can elaborate more on that. Thank you, Naka.
Benako Masese, there's an excellent presentation. There's a question for you about the which legislation you rely on for the management of your catchments. Have you got a legislation for your catchment management, hazard management? We might come back to the questions.
Are there any other questions or just in general discussion, also for anything from Clarissa Samal?
Thank you.
What we can do, Clara, is we might just go to your question, wrap up, and then we can stay online for people if they've got questions. Hopefully our presenters, and you can stay on a bit longer.
So what I thought would be really interesting is after we've done this presentation and heard about the different components and the process of water safety planning, is to put that poll question back out there. So Dean, if you were able to put that back out. And again, ask the same question, and really put that forward in terms of, you know, what are those core key outcomes and objectives of safe drinking water management plans or water safety planning. And while those polls are coming in, yeah, happy to. The risk profiling is a different approach. I found it quite useful. But yeah, happy to ask any other any questions that you might have, or even practical questions that you might want some advice. As mentioned, we're happy to stay on after as well.
Okay. Yeah. Hello.
Hello.
I'm wondering when I thank you for the this is Rima from Maxi with living in Tonga, but we are focusing on people with disabilities. I have listened to the presentations, but I'm wondering how inclusiveness of people with disabilities when it comes to planning in safety drinking waters, as well as how accessible the programs for people with disabilities. This is my questions for the presenters. They see how inclusiveness of people with disability when it comes to planning safety drinking waters, as well as accessible, because this is the challenge for us, people with disabilities as well as elderly people. Thank you.
Yeah, I think one of a really interesting approach is when doing water safety planning, or actually just general planning of infrastructure, or or a general approach, even putting in accessibility to buildings or anything, is to actually do a little bit of consideration of what those disabilities may be and what those impacts may be on that person. So for wheelchair access, for example, there's been plenty of times where newer buildings may have gone in place around in my region that, I haven't even got the capability for wheelchairs to get access. That being said, that could be, what's good is to understand the cross section of your community and understanding, what impairments might be of particular focus within those particular communities. So if you've got, like I said, issues potentially with hearing impairment, sight impairment, wheelchairs, or just general mobility, is really taking through and taking a step back and saying, how is this water going to be accessible to those people, and ensuring that the quality is of a good standard for them as well. But I'm going to hand over to Clarissa or Waf, if you've got any.
I think not only I am focusing on accessible for people with disabilities, but in terms of planning, how can you make sure that the voice of people with disabilities being heard when it comes to planning? Because we have slogan, UN slogan, it's nothing about us without us. So, which is very important in terms of planning, is to make sure there is a coordination between people with disabilities and stakeholders to make sure their voice have been heard, and then they are the one knows exactly what are their challenges when it comes to safety training. I mean, safety drinking water, put it that way. But in terms of how can we develop an inclusive plan for people with disability and elderly people. Thank you.
Thank you.
Yeah, thank you. I think.
I'll speak from community managed networks. For us, the independent water schemes, the workshops are conducted out in the communities, which involves the entire community. It's not just a group of people. We actually invite everyone, children, the youth, as well as the vulnerable community, the vulnerable members of the community. And it's a consultation where we discuss the drinking water safety plan process, and we encourage the input from the different groups in the community, which we then incorporate what we discuss into the plans. So for us, the consultations do involve everybody in the community and not just the water committee, although the water committee are responsible for the more technical side, the management of the network, but we do give the opportunity to the elderly, to everybody for their input. And they can also play a role in the water committee. There's no, again, we encourage participation, engagement, as the theme behind all this is that everyone has a responsibility towards ensuring the water supply is safe, not just a subset group. Everybody has a responsibility. So Yeah, that's my input.
Laura, my question is,
Yes.
are you actually working very closely with Nu'a Olealofa in Samoa?
No, we are working closely with
Sorry, just to interrupt here, we're going slightly over time. So I'm sure inclusivity is really important to all of us to make sure that water is accessible to everybody. So if you have time, I'm sure the presenters have some time afterwards, but acknowledging that some people might have to shoot off to other meetings, we might wrap up the Q&A here, and we are still available afterwards to answer more questions and continue this discussion. But we do have some closing remarks. I might pass to Dean first from Hunter H2O, who will let you know how, if this webinar has introduced some questions in your mind or areas that you need support with, he can let you know how we can move forward with that. And then there'll be some closing remarks by our director from the Pacific Urban and Water Division.
Thanks a lot, Maria. So thanks for joining us, everybody. That's been a really interesting discussion. I just popped up the poll results. So it's interesting to go back and see what the responses were when we started. And looks like people have identified that certainly the operations and resilience is really important. Been a couple of comments there about making sure that water safety plans, as well as some of the other plans that we've been talking about, like the pandemic plans, the water safety plans, financial plans. We'll be talking in our next workshop about asset management as well. These need to be living documents and part of our business. So it's great to see that. So thanks a lot to our presenters. They put a lot of work into working with us to get their presentations done today. So thanks a lot for your time. That was really interesting to see what's happening in the Pacific. And as Maria said, we're here to offer any support. So whether it's on some of the topics that we've done before, the water safety plans today, or anything that comes up. And the TA is still really active. So we'll be talking to all the utilities just about the opportunities to help you under our TA project. So our next workshop, we're looking at asset management and asset maintenance, probably the week after Easter, so maybe around the 14th of April. I'll send a meeting request out and hope to see you all then. So I'll hand over now to wrap up the formal proceedings to Jing Min from the Director of the Pacific Urban Water for ADB to close us out for today. And we're happy to stay on to answer any questions. Thanks for your attendance.
Thank you very much, Dean. Thank you, all the colleagues and the friends. First, many thanks to the speakers, Clara, Clarissa, Moses, Diana, for your very good presentation. Thank you for highlighting the points for us to take away. Specifically, their discussions, I think that's really very, very good. We can see that a water safety plan will not only ensure the safety drinking water, but also will also need to increase the engagement, knowledge sharing, and the knowledge engagement among all of their colleagues. It's also great to listen to Samoa Independent Water Schemes Association and the Water Authority of Fiji's presentation. We can see that their skills are really very, very different, but all facing more challenges in this pandemic time. And also this question, how to develop a water supply plan to cover the vulnerable people. And also, what Clarissa suggested, that to involve everyone in the public consultation. That's really very, very useful. And thank you everyone for joining the webinar, and of course for the very robust discussion. Specifically, I want to say thanks to the friends from Solomon Water, PWWA, Tuvalu Public Works Infrastructure, PNG, and other RANU. I know now it's combined. You are also water PNG, yeah? And also Samoa Water Authority, Water Authority of Fiji, UNESCO, Niue Public Works Department, Nauru Utility Corporation, and Tutato Y. Sorry, I hope I put the name correctly, from Cook Island. and also our friend from Tonga Water Utility. Do I miss anyone? If I miss anyone, please raise your hands. So happy to see all of you here. As our DDG Emma mentioned, this ADB letter is intended to provide support to you, our Pacific water utilities, and also our partners to work together to enhance the WASH practice, to improve the water utilities operation and also the resilience. Of course, from ADB's view, we also want to explore if there's any investment pipeline for the future, because ADB always wants to work with you to do more water supply and sanitation service to really improve the WASH. So if there's anything from today's discussion or otherwise that your utility needs to support with, please reach out to our TA team, to Vivian, Maria, they're all here, and Dean, I think you all know them already. And as Dean has mentioned, our next workshop in the series would be discussing the asset management. It will be held on 14th April, and we look forward to seeing you again there. And then I know the time is a bit delayed, but if you have time, if your time allows, please continue the discussion. I think that's very, very useful. Thank you very much, and thank you for very good organization of the workshop. Have a nice day. Thank you.
Thank you.
Thank you very much, Jingmin. And quickly, before everyone needs to rush off, if you have the capability, if you could turn on your cameras, we might want to get a group shot of everybody. I think this might be one of our one of the most well-attended workshops we've had. I think they're getting more and more popular as we go on. So great to see your faces from around the Pacific. So thank you very much. If you have your camera on, please smile. I will be taking a screenshot. Thanks very much. Everyone's looking great. Hang on, hold that smile one more time. Perfect. And if you, as Jingmin said, have time to continue, we're still here to keep discussing the questions that you've raised throughout the webinar. Thank you very much.
Thanks. Bye, everyone. See you next time.
Thank you very much. Thank you.
Thank you, everyone.
See you later if you're signing off, and hopefully see you at the next webinar.
Goodbye, everyone. Au revoir.
Thanks, Fred. Bye.
Thank you.
Bye-bye.
As people are signing off, if you have any questions, feel free to raise them. I think I don't see Mail still here who raised the questions about